Morning, Johannes. How are you?
I'm good, thanks. Joesph, how are you?
Very well, thank you. Very well. Happy birthday.
Thank you so much.
No worries. Well, thanks for joining Randstad Technology Digital and Data podcast. We'll jump straight in. Introduce yourself. Who is Johannes?
So my name is Johannes Prinz. I'm head of software engineering at Valocity. I've been with Valocity for the last 2 and a bit years, and the company itself's been around for roughly about 6 years now.
Cool. And who are Valocity?
Valocity is a global cloud platform SaaS company, basically focusing on solutions based around property information. So we started our life focusing towards the lender and valuer journey, sort of leveraging property information for them to mitigate risk and sort of streamline the whole, process of buying houses and applying for loans. And we've established ourselves really well in that market locally and doing so internationally as well. So now we're actually expanding our portfolio into all the other different problems that we can solve using property information.
Amazing, amazing. Before we get into yourself, just give us a flavour of the team that you look after.
The team I look after is about 20 strong, a mixture of software engineers, QA specialists, DevOps specialists, infrastructure specialists, and all working together to try and deliver our customer solutions.
Great. So why don't we go a little bit into yourself before we start talking more generally and specifically about DevOps and what you're doing over Valocity. Can you give us a bit of an idea about your background and how you've come to Valocity?
Yep. So starting right at the very beginning, I was born in Germany. My parents are both German. They came over here when I was about 9 years old. So I jokingly always label myself as German made and Kiwi raised. So I've got the engineering prowess of the Germans with the number 8 ingenuity of the Kiwis. So I think that makes a good mix and a good summary of the way I operate. I got introduced into tech fairly on in my life. Started off with my father bringing in a Commodore 64 into the house. And pretty much ever since then, I've been hooked on technology, how it works, what drives it, what you can do with it. So obviously, the only natural choice in terms of a tertiary qualification for me was to do a Bachelor of Science in Computers, which I did and really enjoyed. I was a little bit surprised I didn't get to do quite as much to do with computer games as I thought. Turns out there's a whole nother side on making money with software, right? More business-based solutions. But from there, gone into quite a traditional sort of career path, starting off in tech support for local government, doing network server desktop engineering. Obviously applied a lot of my software development skills to that process. I consider myself quite lazy. I love problem solving, but I've really disliked having to solve the same problem twice. So my general MO is to automate once I've figured it out, so I don't have to deal with it again. So from there on in, my first sort of proper software engineering job was in a consulting company, which basically body shopped IT expertise out to clients. So absolutely fantastic place to start off an IT career. You get to work with lots of different clients, working on lots of different types of products. You get a lot of breadth in sort of your exposure. And then obviously, as you start to learn certain things, you want to know like what happens with the longevity of this. So my next sort of thing that I looked for was to work internally for an organization or specifically on a product. So I did end up on quite a few internal sort of organizationals IT teams. It's quite interesting. Some of them treat their internal team like a consultancy, and others have fully bought in their IT team and they work really tightly with their people. So there I got a bit of a taste of like, I quite enjoy this, being able to build things and getting very quick feedback of whether what you've done is the right thing and whether your users enjoy it and getting their feedback. And that obviously really spurred me on. And from then on in, I sort of made a call to myself and goes, right, I'm only going to work for internal companies on internal products because it's a lot more rewarding. And from there on in, obviously, I went into a couple of SaaS companies, with Valocity being the latest one in that suite.
Yeah, cool. So before going to the practices going on at Valocity, what does DevOps mean to you?
Yeah, so DevOps to me is, at a high level, it's basically just applying the continuous learning process, right? So something that I've always had in my life is wanting to learn more and more, apply continuous learning to almost everything I do. And DevOps is basically applying that to sort of software engineering and how you deliver the thing that you build, applying the software engineering practices. So DevOps being development and operations. It's become more and more prevalent in the last couple of years, mainly because the operational side is being made a lot simpler to start off with. Good example being is Kubernetes is probably a technology you've heard of before. Mm-hmm. To me, that's internet in a box. So you can literally right click, give me a new Kubernetes cluster, and in that action, you basically have internet in a box, because the Kubernetes cluster does everything that the internet does to operate. So, you know, you could imagine you needed teams of hundreds to build an internet type thing back in the day. Now it's almost as simple as going right click, new one of those.
How is DevOps broken down? Because I hear a lot about, obviously you mentioned about Kubernetes, you know, quite a popular tool right now. Can you give us a bit more of an oversight in regards to, you know, what DevOps mean from maybe a mindset, and kind of people talk about SRE and Agile, and, you know, how that, just break that down a little bit. And you mentioned automation as well. Just break that down a little bit, if you would, please.
Yeah, so from a mind, like, to me, DevOps is just a mindset. It's like, what are we going to do? How are we going to do it? Once we've done it, have we done it the best possible way? If we had to do it again, can we do it better? Ideally, if we've automated it, which means now all our learnings, all the time that you spent figuring this out, has been turned into a single button that somebody else can do, so they can build on those learnings and accelerate what you know. So it's from a mindset, yeah, you always realize the more you learn, the more you realize you don't know. And it's by taking your learning and compressing it into something that's really easy for the next person to build on top of, is what the mindset of DevOps is. Applying that to the software engineering practice. And
would you say kind of you have more of a like SRE? Do you have an SRE team? You mentioned you have DevOps engineers.
So we do have DevOps engineers. Their primary role is consultancy, right? So it's about empowering the rest of the team to be able to do operational style activities with a very high quality bar, without having to understand the ins and outs and everything that is involved in the detail. If somebody wants to host a website, they don't want to have to deal with all the things that underline it. Well, a website, what does it do? It has to sit on a virtual machine, maybe, right? That virtual machine has an operating system. That operating system needs to be patched. You need firewalls to secure that thing. All that complexity can be standardized and abstracted away to allow a developer to say, when I want a website, here's a button, send it through that thing, and you'll make sure you have your website hosted on the most secure, most up-to-date, most reliable piece of kit that's out there. And the responsibilities of the DevOps people is that's just that, like, they have a little bit more knowledge about the operational side, and they consult that and make it easy for the rest of the team to be able to deliver what they need to do.
Okay. And What about you mentioned automation, and automation is something that we've spoke about in a bit of detail, you know, during the various conversations that we've had. How, just talk us through some of the process and automation process that Valocity have, just to, you know, make your lives easier.
Yeah, so I usually preach to my team that automation is the testable version of your documentation, right? I mean, if you're describing what you're doing in terms of setting something up, you say step one, do this, step two, do this. The best kind of documentation you can have there is just basically a program or an operation that you can execute, because then you don't have the chance of human error. So automation is absolutely key, and it serves the two purpose of describing what it is that you've done, and also being able to execute and test it to make sure that it still works, whether it's still current. So for me, automation is also that thing where you know, you're creating those building blocks of learnings that you can build on top of, right? So once it's been automated, the only time you really have to delve into it into any detail is when it doesn't work, right? But as long as it works, it's just something you can forget about and build on top of. So it's a common practice. So, I mean, if you do it once, you're sort of in the process of figuring it out. If there's even a remote chance that you have to do it again, and I mean, in the software development lifecycle, you always got, like, you know, build, test, you already have to do it twice, right? So automation becomes the default.
Mm-hmm. Talk us through the technical landscape at Valocity, if it helps kind of breaking it down from when you first arrived at the business and kind of building out the, you know, the technical capability to where you are today. Just talk us through that journey in a little bit more detail, if you would.
Okay, so starting off at Valocity, so I started there 2 and a bit years ago. Valocity is a bootstrap company, so they bootstrap themselves, they funded themselves. So very early on, they had good agile practices in terms of talking directly with the clients and getting early feedback to make sure they're on the right path. And with any startup, your primary focus is on solving the business problems. So you will do whatever it takes to solve the business problems, and you build it out that way. So when I started, there was a nice team of 5 people, developers and engineers, and a business analyst. And that's basically what they were doing, is they're focusing on the business problems. Now, after obviously 3 years of sort of development, you build quite a large repository of assets that make up your solution: scripts, code, instructions, documentation, and the like. When I started, they had just recently automated some of their deployment steps, while previously it was all, you know, following run sheets and checklists of documentation on to deploy. They had recently gone through the first iteration of automating that pipeline. So that was already a good start. So on that basis, when I started, it was all about making that better and faster, and instilling some of the practices that allow us to review not just what we build, but how we build it. And over the next 2 years, we did things like, so we've got a very, when I started, it was all virtual machine based, .NET sort of stack infrastructure. And, you know, you start to notice that every now and then, when you're dealing with a virtual machine environment, is you have to do patching, you know, recovery, testing your DR and recovery processes take a long time, because machines take up a lot of disk space. So it takes a long time just doing copy operations. Mm-hmm. You start to notice that, like, well, if you really had to do it in anger, your availability is going to be impacted just in trying to perform those basic actions. So what are the things that we can do to improve? So, you know, then you start looking at things like containers, right? Because they are small. Virtual machine might be 50 gig, take a whole bunch of time to sort of maintain and patch. Containers, you can go to a container registry, grab me the latest one of them, and they literally take a minute, or in some cases, like just a couple of seconds to boot up and copy. So then you go, okay, that's the better way to go for. And then you slowly start refining your processes to make use of that. So when I started, we had one product, one pipeline, and 5 people. We're now up to 5 people split across 3 squads. We have, I guess, what you call dozens of products or components that we deploy. So that's the other thing is, when you've got a big thing, it's hard to change. Again, it's you've got to have very coordinated efforts of deploying this stuff. So over time, we've gone in and broken things up into smaller, more manageable chunks, which is fantastic because there's some chunks there which are basically bomb-proof. They never change. So we never have to worry about regression testing them because we effectively moved them out so they never have to change. And the smaller chunks that we're dealing with, smaller increments, makes it a lot easier for us to test changes, deploy changes, make changes, and we understand that the scope of risk is massively reduced in each one of those components. So where we are today, like I said, we've got probably close to 50 pipelines, deploying 20 odd individual components, and we're doing that multiple times a day. Whereas previously we deployed maybe 2 or 3 times in a sprint into a test environment, once into a UAT environment, and once into production. Those deployments are now like dozens of them every day into our staging environments, and we're basically at the point where we can push out to production whenever we think, yep, there's enough value in there to ship. So things like hot fixes from discovery to resolution is something now that takes less than a day or even just a couple of hours. And previously, when we started, you would have been looking at maybe a 2 to 3 day turnaround for something like that.
Yeah. One thing, can you explain? Because I know as your DevOps practices are quite big with what you guys are doing at Valocity. Why has your DevOps become so big right now? Can you just explain that?
Basically, it's the reasons that it's become so big is because the solutions that we try to deliver are usually quite complex, but underneath the hood, they're actually made out of many simple components. And there's an excellent quote from Uncle Bob, also known as Bob.
You like him, don't you?
He's a big advocate for the software engineering practice and making it a profession and things like that. And he's from him, I learned almost everything I know about test-driven development. And one of his things that he says is like, as your tests become more specific, your code becomes more abstract. And that's effectively what's happened with our products as well. As the feature set increases, the solution becomes a lot more specific, but underneath the hood, the solution itself is becoming more and more abstract. And that's why it's been split out into so many components.
Just going off topic here, you mentioned Uncle Bob. If anyone wants to learn more about DevOps and SRE and automation and agile practices, where else do you get your information from? Where do you get inspired?
All right. Well, there's a couple of godfathers that I look up to in terms of the software engineering practices. So there's, like I said, Uncle Bob Martin. There's Martin. So Uncle Bob focuses very strictly on sort of the code and the development practices. Then Martin Fowler is the guy that talks to me. I gain a lot more inspiration around sort of the architectural and the component design sort of principles. And both of them should be pretty well known. I'm pretty sure most software engineers have read both their books or the material that comes out of there. Then there's a very interesting fellow called Kevlin Henney. He's a bit of a wordsmith, and he's got some very interesting opinions around how you express yourself just in natural language. Which obviously is really, really important, because one of the key principles of any code that you write, code is read many, many more times than it is written. And the real cost is understanding what the author of that line of code what his intention was. And that's usually the biggest cost. Machines, they understand this. They compile this down and they do exactly what you tell them to. But with human communication, there's so many more nuances that you have to get right, that using the right verbiage or words even in your coding practice are really, really important. I think most developers can relate to this. Like you look through some source code, trying to find a problem, and you go, oh, who the hell wrote this? And then you go, annotate, see, look at whatever your blame system is or source control system, goes, oh, it was me 6 months ago. And just on that basis, you just know, like, if you can write something and you've got good peer review processes, like the chances, like if two of you understand what's going on, the likelihood that your future self will understand this as well is improved, and that becomes really important. So those three guys are pretty much the people that I look up to in terms of the core development process. Now with DevOps, it's sort of a fine thing. So many DevOps has become sort of quite a recent thing, and neither of those three really focus on the sort of operational aspect of the software engineering process, other than like operational side is more of an extension. Like it's something that as a developer, it's your responsibility to deliver value. And writing a line of code is not delivering the value, that's solving a problem. Delivering the value is getting it somewhere so the person who you're solving the problem for, that they can use it. So it's basically applying all the lessons that they learn to actually, don't just build it, make sure you can get it to the person to use it. Because unfortunately, like the pyramids, build it and they shall come, doesn't quite work with software. You need to build it and take it to the people that need it.
Yeah, yeah. You mentioned when we've been speaking, you mentioned the word ship it. What did you say? I can't remember. You mentioned, let's just ship it out. What do you mean by that? And getting it out fast. Just go through kind of that process of kind of how you ship things. You mentioned earlier on that you release kind of multiple releases a day. Just go through that process in a bit more detail, if you wouldn't mind, and what that looks like. And
so I'll give you the sort of spiel I normally give on that front. Is
yeah, I love that.
So like, okay, you've got a person who's got a problem, and they go, okay, cool. How are we going to solve this problem? And go, well, it'd be cool if I could solve this problem while I'm out and about on my phone, right? Cool. All right. So you want something you want to be able to display on your phone. Great. Where else might you go to solve that problem? Goes, well, if I'm at my desk at the computer, I want to solve the problem there. All right, cool. So you're going desktop and mobile. Easiest distribution mechanism we have is a website. All right. So before we do anything, we'll create a pipeline to give you a website. Right? Nothing in it. It's just we before you even focus on solving the problem, you focus on how can we deliver something to you to then create a bit of a feedback loop from. So, evolution, everything, the way your body works, all the mechanics rely on feedback loops. And you might as well take that from nature and apply it to your software engineering practice. The best thing you can possibly do is make first contact with the enemy and actually get feedback from them. Apologies calling my users enemies, but it's from the art of war. But basically you want to prove your ideas. You want to get the earliest feedback to make sure that you're on the right path. So by building a pipeline to ship an empty website, you can now go, okay, what's the first thing you want to do? I want to fill out some stuff. All right, cool. Build a scaffold of a form. It doesn't even need to be pretty. Ship it, right? Is that what you mean? Yeah, sort of, but this last thing, this doesn't make sense. Like, I imagine that to look different. Okay, let's fix that. Is that now right? Like, make the little change, ship it, and getting those type feedback loops, because then you can actually make sure right from the get-go that what you're building is actually solving the problem. And it's remarkable how quickly it happens that, you think you need this beautiful thing where all the problems, everything's perfect and validation, everything's aligned. You don't. You get to a point much sooner than you usually think where you solve the problem and you can go, well, the next thing is I need to solve this problem as part of that. And you actually get to add a lot more value without getting too stuck on the little niggly things, right? And your users that you're building the solution for will actually help you do that. Because if you say, would you like me to push these pixels around and make a pixel perfect and make it all shiny and make the background back? Or do you want the next stage of that process now that you captured in the information, you want to process it somehow? And that, I'll guarantee you, they'll come and say, well, I want to process it. I don't care about the prettiness right now. This is amazing. This has already like made my life 10 times easier. Let's get on to the next bit. And having that feedback cycle is what you can do. And obviously at the beginning, you're just shipping a website, which is fairly simple in the modern terms, but as the solution grows, you slowly build all the other things that ship with it. You know, you might have to ship some services with it. You might have to ship some sort of storage mechanism for it. And slowly that pipeline builds up, but with every part of the solution, you can slowly layer it on, and you know it's just one button to get this thing out the door.
So if you didn't have kind of this DevOps culture at Valocity, and you didn't have this, the creation of the pipelines that we've talked a little bit about, how difficult would it be to get that sort of feedback from your customers?
It would be a lot harder. I mean, then you're sort of starting to fall back into a bit of a waterfall sort of scenario where, like, okay, shipping something's hard, so we want to make sure that we pile enough stuff in to ship. And as you pile more stuff in, more risk gets done, more assumptions are made, and then you ship it, and then the customer goes, it's sort of what I wanted, but really, like those, like now that I see it, you know, it's interesting how humans think. Like, it's for me and you to draw the same picture in our head based on an idea. It's almost impossible. Your idea will be completely different to mine. So if you get to something more concrete that you can show sooner, the more likely you're gonna, hit the nail on the head.
Yeah. So now that you've got these practices in place and you've explained about getting feedback, one thing that I just want to talk about, which has affected all of us, is the pandemic and the lockdown situation. But I think tech businesses, as long as they've had these sorts of practices in place, they've done okay, it seems. A lot of the clients that I speak to, they've got through this somewhat better than other industries. What sort of practices as a manager and Valocity as a whole, what sort of practices you've put in place from a general sense and more so from a DevOps sense to help you through this?
So the good thing is we had a fairly well-established sort of SRE DevOps process already, where we're constantly learning, constantly applying those learnings. So what it actually did is when the pandemic struck, because we had all of those processes already there, it made us very resilient to change. In fact, it allowed us to change really quickly, where we had these components out, and we very quickly went, our main client base can no longer go on site, interact with people to do their job, but we can actually just change where we deploy some of these components to, and give them to the occupants of the house to do the job, right? With guidance from obviously the professionals that would previously go out. So for us, very little had to be done to be able to reshape our solution and ship it for a completely different purpose. That, it wasn't a problem before. We hadn't even thought about it. But then when the opportunity presented itself, it was very quick and easy for us to take what we have and repurpose it for something completely different, because we had all these little parts. It was so simple for us to change a few parameters and reuse all of that stuff for a completely different purpose. So what it enables you to be flexible. It allows you to be adaptable. And that's the key thing. I mean, the only thing I can guarantee you in life is change. Change is the only constant. And part of the responsibility of software engineering, DevOps specialists, whatever you label yourself, is, as well as building a high quality solution, it has to be adaptable to change, because that's the only thing we guarantee.
What other challenges have presented itself by working remotely as a manager? How have you managed that?
So the biggest challenge is communication. It's amazing how many cues you get from talking in person, visual body language that you no longer get. Even being co-located in one place, you might not always be paying attention to all the conversations going around you, but the amount of things you learn through osmosis through that process is actually quite incredible. And that's probably the biggest impact that we've had working remotely, because you no longer get this learning through osmosis, like all your communication and those learnings and even sharing the learning. So, you know, as part of the continuous learning cycle, there's the plan, do, and then the review part. That review part has largely always been osmosis, like learning through osmosis and sharing through, you know, water cooler conversations and impromptu things. So as part of switching to a more remote culture, one of the biggest challenges, how do we simulate those sort of things in a remote environment? So there's been a lot more attention, especially on my part, to try and facilitate those interactions somehow. It's actually quite interesting. So I've always not been a fan of, say, documentation, because documentation is really quickly out of date. And as I said before, my favorite kind of documentation is one that you can run. But being remote, suddenly, I'm sort of starting to change my mind on this. This is one of those fundamental things that I've changed my mind on. It's really important now to start writing stuff down, so you can share that with somebody and say, hey, when you're free, have a read through this, sort of trying to simulate that I'm talking to somebody about an idea and somebody goes, oh, I was dealing with something like that the other day. I know exactly how to solve that problem. This is my experimentation at the moment, trying to figure out how do we improve on those processes? Like, again, how do we simulate all these things that we could do in person, but doing them remotely? And there's some really great organizations out there that have set themselves up for remote first. So they've got really interesting practices around what they call asynchronous communication. And now it's a bit of a thing for us to understand what they are, how they work, and take the pieces that I think will work for us and applying them.
All right. Is there any kind of tips and stuff, just really small kind of bits of tips that you can pass on to hiring managers that might be able to help manage teams remote?
Yeah, so there's a couple of things that I've stolen off other engineers or learned of other engineers. Things like the kind of etiquette that you have when you have your Zoom meetings, Teams meetings, and things like that is, unless you have a really good reason not to, turn on your camera, right? Or if one person can't turn on their camera, everybody turn off your camera, like creating like a even playing field amongst people. Interesting challenges like trying to figure out etiquettes for how do you talk on video, because of the delays that you get. It's really easy to talk over people. Sort of like, you know, a lot of apps now have sort of like put your hand up type thing, and you realize like the facilitation aspect comes into play, where like, oh, you suddenly find like the people in your team who are really good at facilitating, right? And then you find out the people who aren't, and then they go, okay, how can we teach some of those aspects? There's like all these new things that you now need to take into account. So yeah, so there's the putting everybody on a even playing field, including these sort of things in your retrospectives, like talking about not just the things that you're doing and the things you're delivering, but like, hey, that meeting that we had the other day on Zoom, how did that go? Like, what was the audio like? How do we handle that? And then talking within the team and coming up with the ideas there for how we can make things better.
Kind of looking into the future and where Valocity can go from a DevOps perspective in SRE and how to make things better. Where is it from here? What do you have in the pipeline?
So we are literally just scraping the very surface of our problem domain. we've had a couple of sort of days where we got together and sort of chucked together a few ideas of things that we could do, and the possibilities are endless. Our own real constraint is time and resource, as the people to implement the solutions. And for us, it's basically making sure we're set up to scale. We're set up to propagate our learning practices and continuously improve on those. Those are our main priorities at this stage. Of course, I mean, main priority is actually keep delivering values to our customers. But to facilitate that, making sure that, you know, we can build on each other's knowledge and lessons and things like that. I believe, you know, somebody recently mentioned life is not about the wins, it's about the failings, right? Because that's where you learn. And the faster you fail, the faster you learn. And the key is to fail safely, is not to fail so epically that you can't continue, right? That it's game over. So pretty much setting up your practices to sort of make that a priority to address that sort of stuff.
Yeah, you mentioned when we spoke earlier about ownership, and I really like the idea and just sharing upon maybe giving engineers like true ownership and you know, little projects and even budgets. Can you just explain a little bit more about that?
As part of sort of the evolution of becoming a manager, you sort of you notice, like, you're an engineer, you're learning, you're doing, and then you generally progress to sort of like a management level, and you generally your default is to manage by experience. You tell people how to do things, like I've done it, I've learned these lessons, this is how you solve the problem, da 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 da. The real switch sort of comes when you go, oh, rather than telling people how to do it, is how can you empower them to solve the problem themselves? Because they'll learn it quicker, they'll retain it, and they'll take more ownership. And taking that to the sort of extreme, so if I say, well, I've got a budget, I'm just going to take a part of that budget and go, hey, engineer, you have this much to deliver me the solution. And then that actually switches their thinking, not to just like, oh, I know how to code the solution for this, but then go, oh, wait a second, there's a cost involved. All right, so if I spend all of it on just developing it, I haven't delivered the solution. So I've got to allow budget for deploying this, and that includes a budget for the thing that it runs on. So giving them budget suddenly goes, you know, you have this much money, but that means you need to have this in front of the user delivering value. And by just giving them the ownership for that and the responsibility for that, suddenly gets them to trigger. It's like, oh yeah, now I need to think all of these things. And it actually, you know, there's that term full stack developer, which gets thrown around, where, you know, people go, okay, that's a guy that can do front end, back end, whatever. But oh, full stack is actually not just front end, back end, ops. It's everything. It's like, how do you talk to the client, translate their problem into a solution that actually ends up back in front of them for them to use, and deal with that. So, you know, to a degree, if anything, I'd almost like to reinvent that term. Like, full stack should mean that actually that's going full circle back to the old year. That's what a developer did, right? He did the whole thing. He had to understand the requirements, translate them into code, tests, deployment.
Yeah. No, I hear you. No, it's funny. You touched upon a good thing about giving ownership. And what I found in the market is that developers typically leave a business for a couple of things, but one of them, and a really good way to keep your engineers engaged, is to give them ownership and to give them responsibility of a project or of a particular research project or of a budget. That's how you really keep your developers, have a longer, more successful team. And stop losing them. So yeah, no, I get that a lot. Okay, great. I think that kind of concludes everything, really. Is there anything more that you want to add that you just want to highlight?
Yeah. So I mean, we've talked a lot about the sort of ideas behind things, and we haven't dived into anything too concrete at this stage. But the reason being is you know, what works for us won't necessarily work for you. The only concrete thing I can really sort of push and share with other people is whatever you do, make sure you have a review process at the end of it. Treat everything as a tiny little scientific experiment where you've got your hypothesis, afterwards check whether it holds. The same thing applies to pretty much everything, even blameless postmortems is basically just a scientific method. Like we have an hypothesis that like the experiment is basically the incident, and then you need to look at the numbers and find out, well, what steps in our experimentation led to that incident, and what can we do to next time prevent it from happening, and having that in the review process. Like everything you do, review it.
It's been a quick overview, but Johannes, thank you very much for your time. Appreciate it. Until next time.